Hey guys, happy Monday. Okay, so we're going to get started on a brand new unit. I'm really excited about this. I know it's kind of tough when you come in to a class towards the end of a unit, Miss Embry's kids. So I'm just super excited to start something fresh with you guys. And today we're going to really focus on some kind of sixth grade review material. It has been a while, so I'm not expecting you guys to remember everything, but hopefully it sounds somewhat familiar. So we're going to start talking about, sorry, let me get situated here, some ratios, okay? And the first thing I want to talk about is just how many ways there are to write ratios. What I mean by that is if I were to tell you that let's say ratio of boys to girls in my class, for every 3 boys, I have 5 girls. No, this is not true. I'm just making this up, okay? This is a way that I could write that ratio to you. Ideally, if that were the situation, I'd put the unit underneath, but we're just gonna go with it. Another way you can write that is 3 to 5 with those, I always call them the clock dots, a colon, right? And then the last way is to write it in what looks like a fraction form to us, okay? They are all interchangeable. If one is given to you like this, you can change it to this. I don't care what how you write your answers. It might be specified sometimes, or maybe on occasion it's better to use, you know, the fraction versus this, and I will share those kind of tricks with you. So these are the ratio problems you're probably used to seeing where you're looking at the ratio of like a figure to another figure. And so I do want to go over that first. This is what I would call a visual representation. We're going to do a verbal, and your homework tonight actually does a really cool job of combining the two on Delta Math. So let me count. It says circles to triangles. So I need to know the number of these shapes. So I'm going to go ahead and put those out. So there are 6 circles, 8 triangles, and 4 rectangles, okay? So circles to triangles, I can do 6 to 8. And what I really think is helpful here is you writing it as a fraction, because that is not a good final answer for me. It does need to be reduced to 3/4, just like a fraction, okay? Triangles to rectangles, T is 8 to rectangles 4. 8 to 4 or 2 to 1. And I'm going to leave it as 2 over 1 because I do want, it's a ratio of 2 shapes. I want the 2 numbers there. Rectangles to circles, 4 over 6 or 2 over 3. And then triangles to the total, 6, 4, 8, that's 18, or 4 ninths, okay? Again, hopefully this is familiar because I did go through that pretty quickly. Next is the verbal. At Rockwood Valley Middle School, there are 252 students in 7th grade, and there are 12 teachers. I want the ratio of students to teachers. So I'm going to write out students to teachers, just to kind of help me put them in the right order. I've got 252 students for every, I guess, for 12 teachers. And now I'm going to reduce that. So instead of writing it as a fraction and reducing, I'm going to go ahead and reduce it in this form just to show you that it's possible to. 1. And where is it? Where'd it go? Okay, I have no idea where my calculator is, so I got to use my phone. 252 divided by 12. We got 21. So there are 21 students for every 1 teacher. Okay. All right, so let's scoot over here for a second. This table, this is what we're going to do together in our live meeting. I've got some more examples, but I'm kind of going out of order here. So if we just focus on this first one, what we're going to do is we're going to simplify this ratio first. Then we're going to create another equivalent ratio, and then we're going to create a ratio that is not equivalent to that one, okay? This is just going to help us practice for later when we see different ratios, different numbers, we can figure out which ones are the same. So for 3 over 12 or 3 to 12, we can just think about it as a fraction. So I'm going to divide by 3, that's their common factor, to get 1/4 is my simplified ratio, right? Now I could easily just like double this to go the other direction, right? The goal is on this side, the simplified side, what we're really doing is making it smaller, right? For our second equivalent ratio over here, I'd like to make it bigger. I'm going to scale it up, okay? And then one that's not a correct equivalent ratio, I'm just going to add 1 to 6 and make it 7/24. I know that that one is not equal, okay? I'm going to do one more and then save the rest for you guys to do with me in class. Really good opportunity to get lots of participation points. So I'm going to leave those for you guys. So 18 to 12. I'm going to write it as a fraction for myself just to help me. Let's zoom in a little bit. That's too far out. There we go. And to simplify that, I'm going to divide by 2. Oop, there's something bigger. So silly. I'm going to divide by 6. And that would give me 3 to 2. Now, if you didn't see 6 right away, dividing by 2, you would have gotten 9/6 and then thought about 3s to get it even more. And you would have eventually got there, just had one more step, which is totally fine. All right, so we shrunk it. Now I'm going to enlarge it. So instead of doubling it, I want to show you that you can kind of do some crazy stuff. So, I mean, I'm not going to get too crazy, but let's do 1.5, okay? Or let's do like 3.5, something random. 18 times 3.5, 63 over 12 times 3.5, 42, right? As long as you choose, as long as you multiply by the same value, you have created an equivalent ratio that is larger. Again, one that's not equivalent, I'm going to flip them. Okay. So 18 over 12, of course, is not going to be equivalent to 12 over 18, right? There are other options than just adding 1 to a numerator or denominator, okay? Now, when you're done with, I'll show you this again at the end of the notes so you don't have to recall where this is and go back to it. But these 3 are what we will do together for our live meeting. Some other applications of ratios that you will see are determining if I give you a few ratios, which ones are equivalent to each other, okay? This is a perfect example. This is about kids mixing paint in art class to make different shades of green. Students are in art class and they're mixing yellow and blue paint to make a certain shade of green for their art project. I guess I just said that twice technically, sorry. Below are the different mixtures. Which group did not make the same shade of green as the others? Okay, so hopefully we know that blue and yellow make green. Sorry about the hand on the camera again, but hopefully you're aware of that. If not, yes, blue and yellow make green. So we're going to test to see if any of these are, or which one is not the same, right? That there are 3 of them that should be equal. So when you are given a table like this, you need to decide what order you'd like to put things in to test them. You can put blue over yellow, or you can put yellow over blue, but you have to keep it consistent once you start the pattern. So out to the side, I'm going to go ahead and put, do blue over yellow. That's going to be my go-to ratio. So I'm going to take group A and put blue over yellow. Group B, blue over yellow. Group C, blue over yellow. Group D, blue over yellow. So now what we're going to do is divide all those, and we're going to see which one is not equal, okay? So 1.5 divided by 4. 0.375. If it's the same, when I divide blue by yellow, I should also get that same number. Blue divided by yellow. But I didn't. Interesting. So maybe one of these is my answer, right? 4 divided by 10, I can actually see ahead of the game that that is 0.4. So I'm guessing this one is the odd man out. Let's test 6 divided by 15. 0.4. Awesome. So I know that group A did not make the same shape. Now we just talked about equivalent ratios. So in reality, what you could have done with group C and D is get that denominator to both be 30. Okay, if I multiply this by 3, I'd get 12 thirtieths. If I multiply this by 2, that'd be 12 fifteenths. So you can get a common denominator or try and make a list of equivalent ratios. But when I saw the 7.5 and the 4 in there, I thought, man, that's a lot of numbers to try and find a common denominator for. This might be the easier way. Okay, let's do another one just like that. All right, so last one. You're going to determine if the water and flour cups are equivalent to each other. So again, I say just pick a pattern and roll with it. So I'm going to go ahead and do this time. I'm going to swap it. I put the left side over the right last time. So now I'm going to do cups over ounces. Okay, cups over ounces. Cups over ounces. Cups over ounces. Cups over ounces. Okay. Now 1.5 divided by 1 is 1.5. Anything divided by 1 is itself. 3 divided by 2 is also 1.5. So 1.5. Ooh, sorry. Sorry, I'm getting text here. Okay. Oh, not gallery. What am I doing? Sorry, you're like going through my phone right now. Okay. 9 divided by 6, 1.5. And then 12 divided by 8, 1.5. So I have determined by setting them all up the same that yes, all the ratios in this table are equivalent. Okay. Now remember again, your goal is to try to simplify, create an equivalent, and then create one that is not equivalent to technically these 3. Okay. So I'm going to leave that right there. Of course, I have to unshare my screen to stop recording the video, but if you'd like to stop now, you can. I will see you in a minute or in a little bit for our live meeting. Talk to you soon.